Okay, first thing you need is a flashcard. The flashcard should say, this right here, I'll go find it for you, hold on. That one. Here we go. They're asking, for this function, does the function have a limit at x equal 2? So immediately your brain should recall this flashcard. You good? Anybody want to continue? Just wait if you want me to keep going.
Wait.
Oh, you're good.
Oh, wait, yeah.
So when I'm finding a limit, my first thought is always, I check to see if x is approaching infinity. If yes, then I'm going to compare terms that add. Otherwise, I'm going to look to factor. And then once I've done that, I'm going to look for left and right limits. So. Good job, you guys.
Thank you. I have kind of a question in relation to that. Is that okay?
Yes, please.
Where is it? Okay, so one of the limit questions in the practice test A, don't you find the most important thing if it is going to infinity, like 4 to the x, and if x is approaching infinity is way more significant than the plus 4 at the end of the problem,
Yes,
right?
that's the whole idea.
So there's a problem that's like 6e to the negative x. Is it because it's like, okay, I don't know how to say this. I thought
Yeah,
it would
the
be
negative is the problem.
Is that the problem? Okay. Because
Yes.
another one I did was like to the x.
Would it be
one.
like 0?
Yeah, that's what I was wondering. I don't know what it is.
So we'll talk about that one in a minute.
Okay.
But you've got exactly the right idea. The thing that they're successfully tricking you on is the negative
okay.
x.
Yeah.
Good question. Is everybody good here? Okay, so back to here. So what do I do first on this one? Based on that flashcard.
Well, it's not approaching infinity, so you don't have to do that. So then factor.
So someone tell me how it factors.
Well, you can't factor the 1.
Say it, Reese.
X plus 2, x minus 2.
There we go. Questions to that? So now what do you recommend? Good job, Ashton. Julia, question? Yes?
No, will we need to find the left and right limits for 2?
I would, but I'm going to take advantage of the factoring first. And what I want to make sure you've all memorized is this. This is a special fraction, in my opinion. Not just my opinion. What's special about it?
No matter what you plug in, it will always equal 1 unless you plug in like the exact. Unless you plug in a 2, then it would be 0. But if you plug in anything else, it's just going to be a number over the same number.
Cannot explain it better. That's perfect. That's a perfect example of you understood the whole idea. So remembering it's easy because you understand the idea. It's perfect. One little addition. If the top is 0 and the bottom is 0, what value will this have? Undefined. Perfect. Very good. Awesome. In this particular case, however, This formula is not supposed to be used when x has a value of 2, which means this will always be 1. No exceptions. So my formula for f suddenly became much simpler. My formula for f is this. Question? Four? So now what? Now we find the limits. Now we check left and right. So if we're going to do the left-hand limit, let's see. So we do the limit as x approaches 2 from the left. Someone tell me how I think through what to write here. Go.
Well, if it doesn't equal 2, then you would use the top one because it's a little bit less than 2. So then you do 2 plus 2, which is 4.
Very good. So this limit is 4. And how about the right-hand limit, Liz?
Well, you'd do the same one because unless it's exactly 2, you have to use the other one.
Perfect. And we want to talk more about that. And like when Quincy was asking again, like, how does he study for the test without having more problems to practice? What you did as an example of what I was trying to explain. Like when I ask you how to do it, you give all the little details, all the whys. You mention, oh, I have to use this formula because I'm choosing a number that's not quite 2. Perfect. It's like understanding how to, you're understanding not only what to do, but how to, why you do it. So, good here? So somebody tell me, what do we learn? What do we do next? Where are we at? Right hand. Looks good. Let's get Kennedy this time.
So would you just go through like 1, 2, and 3, and so it has a limit at x equals 2, so that's true.
And what is the limit?
4.
4. Somebody else. Liz and Kennedy have checked off their required speaking. Go ahead.
I have a quick question. So the difference between that and the part that says x equals 2 is 1. Is it, and you said that one's 4, is that because it's a limit and the other one, like the bottom part right there in the brackets, that's just saying, like, wait, I don't even know how to say it.
You're doing fine. Say it again. I got lost with that. I got distracted by the flashcard.
So anytime you're trying to find what 2 is, it's just 1, because it just gives you that. You don't even have to like plug anything in.
Correct.
But that's not a limit. That's just saying that x is 1 at 2. Right?
Yes, that's this one here. The symbolic way to talk about that would be that's finding f of 2.
And it's 1. They
And
give
then
us the answer.
that value is 1.
Okay, and so when it's saying the limit, that's different, and that's saying because those two are the same, then there's no jump, and so the overall limit, the left and right are the same, so the overall is 4.
Perfectly said.
Okay.
Perfect. And you can tell I'm listening really carefully to every word you say, because I'm always just listening to see if there's some part of that you're not quite right on yet. You just want to fine tune it. You said it perfectly.
Okay.
Perfect. And you can do that in my room all you want. Like anytime you're just feeling like I need you to confirm something, you just confirm it. Please.
Why didn't we find when x is approaching 2 exact? And
Say it again, Fanny.
like when you find the limits, like at the beginning of the year, we would do like a little bit less than 2 and then a little bit more than 2 and then like right at 2 or f of 2 or whatever, you know?
So we actually have, but there's something that's mixing up, so let's just keep talking. So are you okay with the factoring?
Yes.
Good.
Yeah.
So that didn't involve limits at all. It's just we knew to factor because we're finding a limit.
Yeah.
Okay.
I'm saying like why isn't f of 2 part of the limit?
Oh, just because this is just definition again.
Okay.
It just isn't. Limit means, so when you see this, the limit as x approaches 2, you must force your brain to think x is not going to equal 2.
Oh, okay.
If x is not going to equal 2, what can x equal that isn't 2 but is at least close to 2?
Okay.
Tell me the answer to that question. Like x can't equal 2,
has to like be a little bit less or a little bit more.
Right. So when you see this, your brain automatically says, oh, I don't pay any attention to this really.
Right.
I go do this.
Oh, okay.
If that makes sense.
Yes.
If these two turn out to be different, then this two-sided limit will be non-existent.
Oh, non-existent?
Non-existent is the
Oh,
word.
okay.
That would be a whole, right?
That would be, if these two are different, that's a jump.
Right.
Yeah.
Would that also be discontinuous?
Yeah, because jump is a discontinuity. And it all ties together.
Yeah.
If you keep tying it together, your brain's gonna get happier and happier. Because the only way for the function to be continuous at x equal 2 is if all three of these are the same. That's my three-finger thing. And that was this flashcard back here. Too many pages on this dumb file. Come on. That one.
Okay.
That's exactly what you're talking about. So f of 3 is totally different than the limit.
Mhm.
Because limit means just get close. Don't be 3.
Okay.
Did that answer your
Yes.
questions? Awesome. You're very good at questioning. Don't cease to be that way. Are we good? Oh, please.
So if the limit, like a little bit less than 2 and a little bit more than 2, if both of those are 4, then would you say the limit at 2 is 4?
Say it one more time, please.
So if the limit less than 2 and the limit more than 2, if both of those equal 4, then would you say the limit at 2 is 4?
Awesome. Your thinking is 100% correct, I believe, but I want to avoid one of the words you said. You said the limit at 2. We don't want to say the limit at 2, that's misleading, because the limit can't be at 2, really, because we're not going to ever have x be at 2. It's the limit as x approaches 2. So we don't want the x value to be 2 ever in a limit. We want the x to be almost 2. We want it to approach. So I'm going to try and prevent myself, I probably said it that way before, honestly. I said, oh, the limit at 2, but better to say the limit as x approaches 2, so you don't make the mistake of thinking the value is 2. But I said like the
Oh,
same
yeah.
thing 16 times there, and
That makes sense.
probably was
yeah.
super confusing. You
Yeah.
okay? Please.
Is that what you mean when you say like the overall limit? So like once these two limits are the same, then the overall limit. So the overall limit, you can find it just by finding the left and the right, and if they're the same, it's that number, and if they're different, it doesn't exist.
Let me say it back to you. The only way to find the overall limit is to find the left and right.
Right.
There is no
Can't
other
find-
way,
Okay.
because of what I said to Kennedy. So you say it back to me. If we're going to have x approach 2, but not equal to, what value can x have?
It can be a little less or a little more.
That's it.
And so that's how you can find it.
That's how you find the overall. I kind of need to stop calling it overall. I think it's easier to remember if I keep calling it the two-sided limit.
Right,
This means two-sided limit.
right.
You've got to check both sides. This does not mean x equal to. That's what this means.
Okay.
Perfect. Anybody else? Awesome. So now what do we do?
You just go through the list.
Keep going, Kennedy. I only put it back on you because you learn far better if you're the thinkers and I'm just kind of guiding where necessary. Like ultimately, if I could find a way to make it so I just kind of wink and blink and you guys keep talking, it would be best. But you think, the more you think, the better. So keep going.
So the second one is define that x equals 2. Would that just be in, like, is that a function right there? That green
Just
part?
tell me to the green. Yeah.
Yeah. So what does that mean, define that x equals 2?
Got it.
Would that be part of it?
So a function's definition is the formula that is used to create the list of x, y pairs. With me? Or you could think of the graph as being the function's definition because they've just given you a picture of all the x, y pairs. So when you look at this definition of the function, when they say f of x is defined for x equal 2, they're asking you to figure out, well, if you're making a list, at x equal 2, would we find a y value?
1.
1.
Okay.
Connections, again, 1 second, Liz, sorry. Saying that f of x is defined, now this came up on some other problems. Saying that f of x is defined at x equal 2, that's exactly the same as saying x equal 2 is in the domain of f. Does that phrase sound familiar? Those are equivalent statements, and they'll test you on who knows which one, but they mean the same thing.
That answered my question.
Awesome. Please, Reese.
So is f of x being defined at x equal to like the same thing as it being continuous at x equals 2?
No, good question. See, I cut you off too quick, sorry.
I just said like how is it being defined at x equal 2 and being continuous at x equal 2 different?
Gotcha. So defined at x equal 2 only gives you one of the 3 required points. So all you know is this. To be continuous at x equal 2, you've got to find the other 2 points. The ones that are nearby.
The other two meaning the
Left
more
and right
negative.
limit. Yeah. You have to have all 3 for the function to be continuous when x is 2. Here's why. So this particular function, Reese, is this function continuous or not continuous at x equal 2?
It is continuous. If both of the left and right limits are the same and there's a value at x equal 2, then wouldn't it be continuous?
Oh, close. So the flashcard you're looking for is not that one. We went back to it. Let's find it again. So we're looking for this flashcard. We want to apply, good job, Kaylee. We want to apply, I said Kaylee and apply all in the same breath. We want to apply, we want to apply this flashcard. 1 second. Okay, we need to apply this flashcard right there to the problem we're working on. So in our case, it's x equal 2. Let's see, I could change all that, although it's, now I've started, I can't stop myself. Good job, Alan. Is this true for the problem we're working on? Let's get Reese to look at it.
Well, if x equals 2 is 1 and both of the limits are 4, then is it not true?
Correct. If I were trying to draw a picture of this graph, here's what I'd get. A little less than 2, the y-coordinate's really, really close to 4. A little more than 2, the y-coordinate's really, really close to 4. Right at x equal 2, the y-coordinate is 1. So on a graph of f, we would see something like this. Here's x equal 2. Right at x equal 2, there's a dot. Just infinitesimally to the left, there's a dot as well, but it's way up here. Just a little bit to the right, the dot's way up here, and so you'd have this open circle in the middle. So it's a removable discontinuity, because the left and right match, but they don't match the value of the function. So it's definitely discontinuous. Reese, what would be a very, very simple change to the problem way up here that they could make, which would have made this a true statement?
Both of the limits would have to equal 2. So if like that top function was just like 1,
Oh, there you go.
x could equal 2.
So both, it's true, if this function were just 1, then the limit from the left and right would have equaled 1, and the value of the function would have also equaled 1. That would work.
You could also just say if x equals 2 is 4.
Correct.
that would work.
So change this to a 4, leave everything else the same, then all 3 will match. Perfect. You had a different question, Reese. I don't know if I got back to it, but I think you're okay.
Oh, I think you got it.
Okay. The reason this one here If these three are the same, the graph you end up having is three dots all right next to each other. And that's what causes the function to be continuous at a point, so. Other question? Oh, please.
Oh, not on this one.
Anybody else have anything here? Solid. Liv, you're